Okay, I'll try to explain how this circuit is constructed step by step. So if you have not gotten the software, just go to deeds, just Google search and then look for this website and go downloads. Yeah, and then just download the latest version. Yeah. So once you download it and install the thing, you have three shortcuts. And for this project, we use DCS, Digital Circuit Simulator. Okay. So when you open the software, you'll come up with a blank circuit. Yeah, a blank circuit. Okay. So now I'll try to cover some of the basics first. So if you want to construct a wire, just right click and click wire. So you choose any spot. So they have a grid system lah, like X and Y coordinates, that kind of thing. So you choose a spot and then you click. After you click, then you move around, then you select another spot, but it must be on the same vertical or horizontal line lah. So either here, let's say I choose here, yeah. So then I can continue. Yeah. So if I want to stop or choose another position, then I press escape. Yeah. So I click here and then click here. So press escape. So as long as you see this cross, this X, it means that you are ready to place a wire. So if I press escape again, then there's no more X. Means I'm not in the wire mode. I mean I simply click, I only can select. Yeah. So as long as I go into wire mode, then the X will appear. Yeah. Okay, so I can select the whole thing and delete. Yeah. Or I can click individually and delete lah. Yeah. Okay. So now next we will go into the input. So you got two types, input switch and input push button. So what's the difference? So I'll demonstrate to you here. So and then another thing that we have is output. So if you want to test like whether the wire is high or low, you just use test LED. Yeah. So I'll just place two test LED here and I'll construct a wire to connect both. Yeah. So you can't connect both directly just like that. You see, error. You need to have some sort of wire in between. I don't know why they design it. They design it this way. Yeah. So when I press play, okay, wait, I'll save it first. Okay. So when this is the push button. This is the switch. This is the push button. So switch means like when I press once, you go to one. When I press another time, you go to 0. Push button means as long as I hold it, press and hold, it will become 1. But the moment that I release it, it becomes 0. Yeah, that's all. Okay, so now these LEDs are useless at the moment. So now, oh yeah, another thing is that when you place any component lah, if you want to rotate it, just right click. So right click and yeah, it will rotate clockwise. Okay, so for this purpose, uh, I'll just copy. Too lazy. Okay. Okay, so I'll just copy and paste it here. Oops. Okay, yeah. So now we have 9 inputs: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when you place it or you select properties, you can change the label lah. Like label is the name basically, and then starting at time is 1. You see, but if you want to change starting to 0, just go to properties and then change to high, then click the tick, then now it will reverse. Yeah. So for the numbers, right, we'll be using a push button. Means like when you play it, it'll be push. You just push up. It's not like click once and then you change. No, you need to hold it. Yeah, that's very important. Very important distinction. Okay, now these wires, right? These wires, this special blue color thing, they are called buses. Okay, so now buses, right? Wait. Okay, so now buses, they are actually a collection of wires. Like just now, uh, like just now, we can create one wire, right? But if we were to create a bus, see, if we were to create a bus, okay, bus, so you can choose how many wires inside the bus. A bus is like a collection of wires lah. So let's say I want to choose 4 wires, so I can construct. So inside here I have 4 wires. So when you go to properties, right, bus indexes, you can choose the range. Means like now got 4 wires, so you can 1 to 4 or 2 to 5, so your choice lah. So for now we just use 0 to 3 lah, the practical, the standard way of labeling the wires. Okay, so this one is label just for fun, and then yeah, that's all. So if you want to uh, connect a component to the bus, normally for normal component we use wire, right? Yeah, but for bus you need to use a wire tap. You use a wire tap. This thing, bus tap, sorry. So this triangle thing on the bus, right, will be on the bus wire. Yeah, so you can see I put on the bus wire, and then you choose you want to connect that wire, that bus tap, to which wire in the bus. So let's say I want to choose, okay, I want to connect that wire to wire number 3 which is 0 2. So I put okay, then that's all. So now I just connect it here, and then but you cannot connect directly to the bus tap. You need to put somewhere near and then add another wire. I don't know why they design it like that, but very weird lah. But it's weird, but that's how it is. Okay, so that means this button here, this one is connected to the third wire, because we start at 0 0 mah. So but the third wire is 0 2, so as you can see 0 2 means connected to the third wire. Okay, so that's all lah. That's the bus. Okay, and then now you see here, but for this bus wire, right, this one, our index start from 1 to 9, our range. So in this bus we got 9 wires, see bus size 9 means we got 9 wires. So our range start from 1 to 9. Yeah, so that means this button 1 is connected to the first wire in the bus. Then this one connected to the second, so you see 0 1 0 2, yeah, up to 0 9. For the 0 button, this one, button number 0, we don't connect to the bus. We will use it later on lah. Okay, so so now we can see another nine bus tabs to connect the wires out to another component lah. So now we will move on to this thing called the priority encoder. Yeah, okay, so this is the priority encoder. Now if you can see these bubbles here, right? So these bubbles are actually inverters, which means that if I put, let's say I connect wire here, okay, and the input of this is 1, that means instead of 1 going into the first one, it will be actually 0, because this bubble will invert. So if originally is 0, then it will detect as 1. Yeah, so you will must take note of these bubbles are very crucial. Yeah, so I'll demonstrate to you, like okay, this priority, okay, before that I'll explain what's priority encoder lah. If it's these are numbers only, so what the priority encoder does is it will convert the number to BCD form, to a 4-bit format, which means that which means that if I connect 1, if this input of 1 is high, then this Q3 will be 0, Q2 will be 0, Q1 will be 0, but Q0 will be 1, because 1 you convert to binary is also 1. So for example, if I put 5, so it will become 0 1 0 1. Yeah, that's all. But because of this bubble, instead of 0 1 0, instead of 0 1 0 1, it will become 1 0 1 0. It will invert. Yeah, so what I should do later is add this what you call it, add this complementer, so you can access it at tools, no, circuit, component, arithmetic circuits, complementers, and then now since we are using a bus, so we choose the bus lah. Yeah, okay, so this complementer is very simple. It will just complement the thing lah. This is your input, this is your output. Okay, and then if this is 1, this have to be 0. If this is 0, this have to be 1. They cannot be 1 together. Okay, so if complement is CPL stands for complement lah. If complement is 1 means you will do 1's complement. That means if 1 1 1 1, here will come out as 0 0 0 0 0. Yeah, And then two complement means two complement lah, like we learned before. Yeah, so you choose either one lah. For this project we will just use one's complement because we just want to flip everything we don't want to add one. Okay, why we want to flip everything is because the output of this priority encoder got one bubble, got bubbles, it will invert the final output, so we need to invert back to the original form. Yeah, I don't know why priority encoders have these bubbles, but it's already fixed like that lah. So we just have to adapt the program to the need to what is already available. Yeah, so basically okay, let's say I were to connect to 5 for example. Okay, uh I'll just demonstrate to you. So and then we'll have one LED. Yeah, and then okay, never mind lah, we will skip this. Never mind, no point. Yeah, I'm sure you understand what the priority encoder does. So what's uh important here is that every input here must be 1. Yeah, and then the number that you choose, let's say I want to choose number 3, that input must be 0. Why? Because of this bubble there. Yeah, so that means that's why all our buttons here start at 1. Yeah, start at 1 is because if I don't click anything, your number will be 0, right? So all 1 will go in here, 1 1 1 1 1 1, and then the bubble invert everything to 0 0 0 0. So in the end your output come out here is 0. Yeah, so like I said just now, we are just doing this to adapt with the program lah, with this software lah. Okay, it's a very annoying thing, but it's just a minor annoyance. Okay, so I'll just connect to this tab. Okay, bus tab. Okay, so now the bus wires, you see, all connected to this priority encoder, but you need to have 9 bus tabs because you need to separate out, take out one by one. Yeah, okay, okay, so now you got 9 input already, and the 0 we don't care, and so you need to complement the thing. So what you need to do is you see you have another 4 bus tabs because you want to connect to the bus wire. Yeah, so I'll just copy this. Okay, and then okay, so I'll just connect here 4 bus steps, then this complement, but this complementer is a bus, you see, so you just connect to one of it lah. Yeah, here for example. Okay, so we're done. So this output at here is inverted, so you need to invert it back again, you get the original one here. Yeah, okay, like you see here, invert it, then you get original one here. Okay, so yeah, what we do is uh, okay, just copy pasting lah because I'm too lazy, you know. And then don't forget to choose whether it's 1 or 2's complement. Yeah, so like you see here, we are choosing 1's complement. Yeah, that's all. Okay, and next we need to consider, now we will need to consider this multiplexer. Why? I'll explain later lah, actually. I'll just put it there first, so I'll explain it later. Yeah, okay, uh, so like now we need two registers and 2 multiplexers. 1 2 2 multiplexers, 2 registers. Yeah, okay, so why we need those two? uh okay, I'll explain one by one lah. So I'll start with the register first. Okay, okay, so now we got 2 multiplexers, 2 registers. Okay, and then you connect the bus lor. Yeah, so they will automatically size it for you lah, I think. Yeah, I see. It somehow remembers the setting lah. I think this software is quite well built, quite well programmed. It's quite efficient lah in a lot of things. Yeah, so Yeah, so the efficiency depends on yourself lor. How efficient depends on how good you are at using it. So I'm not very efficient. Suck at this. Oh crap. Accidentally close it, sorry. My bad. Yep. Okay. So now what happens here is that we have one multiplexer here, okay? Oh yeah, I forgot. We have we must consider this also. Okay. So we add this first and I'll go one by one lah. Ay, suck at this. Okay. Okay. So now we have this power clear and another button called hexadecimal. Hexadecimal, right, is to change the display. Yeah. So this one will cover the last lah. We will start with power, clear, add, delete, and equal. So we will start like according to order of power, then clear, then add, delete, equal. Yeah. Actually the development of this circuit follows that order. Yeah. So I'll start with power first. Okay. So this power, right? Basically when you click the power, right, then you on the circuit. Yeah. So I'll just demonstrate to you when I press play. Like you see the two displays are off. Then when I press power, then tada, they're on. Yeah, that kind of thing. So that's the purpose lah of power. That's all. And so for this purpose, we need to use this D latch. Yeah. Okay. So this D latch, right, is to basically go from 0 to 1. That's all. Yeah. So I will uh, just connect the power to the preset of the D latch. Like you see this power, follow the wire, then connect to the preset of the D latch. Yeah. I think I'll just refer to this circuit. I won't construct the whole thing again because I think it will take too long and then you'll be bored by then. Yeah. So I'll just use this to demonstrate anything extra. Okay. Yeah. So I'll focus on this one first. So okay, this power connect to this D latch. Okay, the preset lah, the preset. Which means that when this power turns to 0, then this LED, this Q will become 1. Okay, originally, right, before you do anything, this Q is actually there's no state, there's no defined state. It's neither 1, it's neither 0, it's in undefined state. To demonstrate to you, I'll just add another LED, output test LED, and then put here. Okay, now you see when I press play, see what's the initial state. It's red color, it's not black, it's not blue. Blue means high, black is low. So what about red? Red means undefined. It's nothing. There's no undefined state. That's why like you see at this here is undefined. That means totally it's neither high neither low. Yeah, it's like in between lah. So when I press power, it becomes 0, and then this preset is when it becomes 0, then this preset will cause the Q to become 1. Yeah. So when I press power again, nothing happens because it's already set the Q already. And then my D empty and then my clock also empty because for this purpose it's useless lah. All the purpose of this D latch, right, is just to keep that power on state. Yeah, just for the starting only. Yeah. So that means if other than that, if I do any other thing, it won't work lah. It will only work when I press the power and then starting the time, then this will be high and then it will enable everything else. Yeah. So that's the purpose. Okay. And then since I won't reset the thing, I won't off the circuit, so my clear just connect to 1 lor. Yeah, that's all. Okay, so you can see you go all the way down, go all the way down, and then this one will connect here. Yeah, and then this part we will cover later lah. Okay. So next we will focus on these two guys. Okay. The application of these two guys we will cover later, but what is this for actually? So this is to detect either power or clear is clicked. So demonstrate that, I will add another LED. Okay. So when I press play, See how when I press power, this LED will become 0. Yeah. So when I press clear, this LED also becomes 0. Then when I release it, it'll be back to 1. So this, the purpose of these two guys is to detect whether power or clear is pressed. Yeah, either one lah. Why you need to detect that is because I will connect it to the clock of uh, this parallel registers, and when you click power or clear, it will reset them to 0. Yeah, that's all. It's like you see just now that this wire just now connected to just now the two NAND gates, and then you see they are connected to the clear portion of this parallel register, and then clear portion of this clear portion of this parallel register only, sorry. The clear portion of this parallel register is connected to another part, which I will show you now. Okay, it's connected to this one. Yeah. So this part, the function is the same as this. This one is to detect whether power or clear is clicked, but this portion here is to detect whether delete, or if you trace delete or clear or power. So that's the difference. So this one is power or clear, this one is power or clear or delete. So you see 3 inputs: power, clear, delete. Yeah, so that means it's either power or clear or delete is clicked, then uh, the LED, this output here will be high, it will be low, sorry, because I mean will change basically. The most important part is the change. Yeah. So when I click power, you see this guy change. Yeah, that's all, it will change. And then why you want it to change is because when it changes to 0, then you'll reset this register. And then if either power or clear is clicked, you'll reset this register and this register, both registers lah. But if delete is clicked, it will only reset this guy. Why this guy, this register, and not this register? I'll explain later. Okay, so I need to clear these concepts first. This one is like a click detector, a click detector like that. Yeah, it's just a click detector. Yeah, that's all. For fun, not for fun lah, sorry, I keep saying for fun, I don't know why. Yeah. Anyway, so like when I click power, then this thing will on. So the on. Okay, now this add, right, okay, is connected to this NAND gate. Okay, this NAND gate will invert lah, so the add currently is 1, it's actually becomes 0, and then 0 NAND with this on, so this one become 1. Yeah, so the moment I press add, it becomes 0, right, and then 0, then here become 1, so 1 and 1 becomes 0, so it will clear, it will reset the queue of this uh, D flip-flop. So if here is 0, and then here will be 1 lor. Yeah, so uh, when I put an output here, you see, when I press power, originally is 0, when I press add, suddenly become 1. Yeah, so this is like this, so I'm just showing you that because I want to demonstrate the usage of this D latch lah. It's very useful. It's just you don't play around with the D, you don't play around with the clock. All you need to do is play around with the clear or preset. Yeah, that's all. Is that useful and straightforward. So this is clear is to turn the zero Q to 0, preset is to change the Q to 1. But for this case, I was just using the inversion of Q lah, Q bar. Yeah, because I have to use Q bar lah. Yeah, for this case. Why depends on how you construct a circuit lah. For the way I construct this circuit, Q bar is the best option. Yeah. Okay, so you can see, right, when I press add, I keep track. Then when I press delete, it will reset this D latch, and then it will not reset this D latch, it will change the Q to 1, so my Q bar is 0, you see. So you see, add and then delete, you can reset the states, you see. So using clear and preset, you can change the state of this D latch and keep track lah. Like let's say the user want to add a number, so he press add. Okay, but now the user changed his mind. He doesn't want to add a number. He wants to change the first number again. So you press delete, and then he will reset. He will clear the add state, and now you're back to scratch, back to square one, back to the initial state where the user have to choose one of the number. Because the process is like this. First the user have to choose a number, and then have to click add, and then have to choose another number. But let's say if I click a number and then I click add, okay, so now the circuit already detect, oh, the user already click add, so now it's time to select the second number. So now the user can choose any second number. But suddenly the user change his mind, oh no, I want to change my first number, so you press delete. So what happens is it will reset, it will kill the add state and go back to the initial state where the user had to choose the first number. Yeah, so this delatch, right, is just to keep track lah of the state only. And when you want to reset the state, you just connect to either clear or preset and then the other way around you connect to the opposite lor. Yeah, your choice lah, it's the same only. Yeah, so where should I focus now? Okay, back to the priority encoder. Okay, so back to priority encoder, if I click a number, okay, let's say I click 2, so here will come out as 2. Okay, when I click 2, here will come out as 2. But now when I click and hold here, this part will come out as 2. But when I click, hold and release, right, after I release, this will go back to 0. Yeah, so you will lose. To demonstrate it, I will show again lah. Never mind, I can't demonstrate. Wait. To demonstrate it, I will put a 7-segment display with a bus to the bus. Yeah. Okay, and then yeah. So if as you can see here, now you have an invert, so it's F. So when I click, then it will go to, it's supposed to be 8 lah actually, but because because of this bubble it inverted mah, so it becomes 7 lor. So when I release the button, then it will go back to 0 again. When I press, it will go to that number. So you will always lose, you see, the moment you release the button, you lose what number the circuit will forget what number the user pressed. So now what you have to do is add this what you call it, parallel register, this guy here. Why you have to add this guy here is to keep track lah of the state. Yeah, so now never mind, I'll just keep that here. Okay, okay, I'll just delete lah, no point. Okay, so now here is inverted, right? So now you need the complement and invert it back to normal. So now I'll show you. When you invert back to normal, then you get the normal number lah. Yeah, so when I press play, and then you see when I click 8, this guy here become 8. Yeah, but you'll always go back to 0 the moment you release. Yeah. So that's all. Oh, now I have a multiplexer here. Now why do I need a multiplexer? Okay, what's the purpose of the multiplexer at the first place? Okay, so I'll demonstrate to you a multiplexer first off. So assume that we are using a normal wire, so I'll just use a 2-to-1 multiplexer. Okay, these guys are all useless. Okay, a multiplexer basically choose, okay, these are the two inputs. So a multiplexer basically choose either one of these input. Okay, and this guy, this S, is actually a switch. Okay, so if I have an input lah, okay, if I have an input and then I connect the wire to here, so when I press play, right, this input will either be 1 or 0. Okay, so if it's 0, then it will select this guy, this part. If it's 1, it will select this part. So to demonstrate to you, I will I'll put two different logic levels lah. One is 1, one is 0. Oops, sorry. Yeah, okay. Okay, and then another output there. So always use test LED, it's very useful to look at individual outputs. Yeah. So I press play, then okay. Then when I see when it's 0, right, you will select this I0. When it's 1, it will select this I1. Yeah. So if the input of I1 is 1, then the output is 1 lah. If the input of I1 is 0, then the output is 0. but if I select the other one, then this I1 is useless already. You only have to bother about I0. Yeah, so it depends, like a switch. Yeah, very useful, very useful. Yeah, if you don't use this, you will end up like uh the one I did initially. This guy with so many AND gates, oh, wasted like 4-5 hours on this. Yeah, and if you're smarter, then and if you're smarter and you use multiplexers, you come up with an elegant circuit like this lah. It doesn't look so elegant, but much better than this now. Yeah, so much better. Okay, so this multiplexers here is the same like this now, just that you're using a bus. Okay, not van, not taxi, but bus. You are using a bus. Okay, and now the switch to this bus is this S, right? So we connect it to delete, which means that when delete is 1, you see delete is connected to that. I'll highlight it here. Delete is connected to the switch of this multiplexer. Okay, so when delete is 1, then I will select I1. When delete turns to 0, then I will select I0. Yeah, that's all. And the output is here lah. Yeah, so the output of this depends on delete. Depends on delete. Yeah. Okay. Depends on delete. The output of this depends on delete. So like when 1, then this output here is actually this one. When it's 0, then this output here is actually this one. Yeah. Why? I will explain later lah. Okay, so the output of here come out already. Okay, now you branch into two parts, here and here. This part I don't care first. I will leave it later because a bit hard to explain why I decide to add this complicated. It looks complicated, it's not, but why I decide to add this extra thing lah. It's actually a bit unnecessary, but I'll explain why. Okay, so now this output will connect to this parallel register. Okay, now this register that we're using is called parallel in, parallel out. Okay, you can study it yourself lah in lecture note. Okay, now I'll just demonstrate. I'll just try to explain a bit. So you got parallel in, parallel out, parallel in, serial out, series in, parallel out, and this series in, parallel out can be also series in, serial out lah. So for now we are using PIPO, people. Okay, so 4 bits pass. Okay, so this 4 bits parallel in, parallel out, you got the input, you got the output. Okay, so if 4 input, then 4 output. If 2 input, then 2 input, 2 output, sorry. Yeah, and then this is your clock, this is your enable. Enable means you enable it lah. If the input of this enable is 0, then this register is off. If this enable is 1, then this register is on. So like you see this register, I connect it to this part. So like now when I press play, initially the register is off. Okay, this enable, connect, you trace back all the way here, and then go back up, go to this. You see originally it's off. When I press power, it's on high, so it become on. So I activate everything lah. So the enable of this connect to that. This now up here, and then the enable of this guy, this second register also connected to that. Okay, so now where are we? Oh shit, I'm lost. Okay, never mind. Yeah, so the output of this multiplexer connect to the input of this register. Okay, and then as long as my clock changes, right, the input to the clock from 0 go to 1, or from 0 go to 1, then this input here will shift to the output here. Yeah, so originally let's say this is 5 lah, the number is 5, and then the output of here is 0. Yeah, so if I change to 7 or change to 8, nothing will happen in the output. But as long as I change from 0 to 1 in the clock here, then it will shift the input to the output. Yeah, to demonstrate it, I will again add this, what you call it, 7-segment display. Yeah, so this 7-segment display, right, I connect to the input and the output of that lah. Okay, so the input of that what is it, this register, I connect to the 7-segment display here, and the output connect here. Okay, so to demonstrate, you see when I press 8, see number becomes 8. Oh sorry, wait, I need to on the circuit first. Yeah. Okay, so when I press 8, this number become 8. Okay, press 8, this number become 8, but this number will not change. Okay. Oh no, will not change if the clock never change lah. So like if I remove the clock, okay, the clock is not connected to anything, you see. So nothing changes at the clock. So you see when I press 8, then nothing happen lor. Yeah. So the clock is very important lah. The clock will determine whether this input will masuk into this output. Will shift into this output, yeah, not masuk. Yeah, sorry. And then yeah, that's all. So uh okay, now why must we have this? Okay. So what happens here is that I connect the output of this to the complement, and then I complement it lah. And then I put the AND gate to the 0. Yeah. So now this is where 0 comes in lah, the 0 button. So this part here, I won't go into further detail why it works, but all it does is it detects whether a number is pressed. So like I will just connect I'll just connect an LED here, okay, an LED, and then we will see what happens. Okay, so when I on this circuit first, okay, actually no need to on lah, pointless as well actually. But okay, when I press 5, you see this turn on. When I press 4, this will light up. Originally it's 0, but when I press any of the numbers including 0, it will light up. So it's just like a click detector, click detector, just like the earlier part, with power, clear, delete. It's the same lah. It's just a click detector. And then why you want to detect the click is because you connect it to the clock lor. That means when I click on a number, when I click on any of the numbers, this clock will change, and then he will transfer the input to the output. Yeah. Otherwise I cannot transfer, you see. So I want to shift the input to the output whenever any number is changed. Yeah. That's what I want to do. Okay. Now yeah, so that's the purpose of this thing lah. Okay. There is also another way to do it. I tried, but it failed. I tried it here lah. I tried to put this NAND gate here, and then connect all the inputs here, but it failed. Why it failed? This is very important lah. Because of the delay. You see if I put here and then I connect all the buttons to this NAND gate and then connect directly to the clock, it works. Theoretically it works, but practically it doesn't, because the clock will change first and then only the number here will change. Let's say I press 5, here it should become 5, right? But before it becomes 5, it's originally 0 mah. But the thing is, when I press 5, this guy will detect and switch the clock. But when it switches the clock, it never detect the 5, it detect as 0, because the current flowing through here is faster than the current flowing through this circuit. Yeah, so that means my 5, this 0 here should change to 5, or should change to any number you press, but it only changes very slowly compared to the clock. So your clock will detect only 0, and then only your number will change from 0 to 5. So in the end it doesn't work lah, it doesn't transfer because of the delay. So this software is like super awesome, I tell you. It also considers the delay, of the circuits. Yeah, of course the delay in this part here is much higher lah, because you have to go through the priority encoder, and then go through the complement, go through multiplexer, 3 things, of course it will take very long lah. Whereas this part here, you only go through the NAND gate, and then straight we go to clock, so it's like no delay at all. So it's like very fast, super fast, too fast that it becomes a liability, too fast until you cannot achieve what you want. So that's very annoying, but I think it's very good lah. I mean, it's more realistic. Yeah, so I had to shift from here to here. Yeah, so a bit troublesome, but it's very no choice lah. Have to adapt with things. Yeah. Okay, next we will move on to this multiplexer here. Okay, so this multiplexer here, the switch is connected to the add button. You see, I trace it red, 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 and go up until this sorry, delete button. Sorry, made a mistake. Yeah, delete button, not add button. So that means the moment I press delete, right? The moment I press delete, this multiplexer this multiplexer will decide whether to choose this input or choose this input. Yeah. So when my delete is 1, so we will choose this one. If my delete is 0, it will choose this one. But if my delete is 0, then you see here is all 0. This is a 0 logic level. And then I connect all 4 wires to 0. Why? I'll explain later lah. So which means that when my delete is 0, then this input will be 0 and this output will be 0. And then this register also will become 0. Yeah. It is actually because, okay, why it's actually because this parallel register second one will store the first number that the user choose. Like to demonstrate to you, I will add another hexadecimal hexadecimal block, add another bus. Yeah. So what happens is that when I start the thing, then I press power, then let's say I choose 5 lah. Okay, so you see this 5 is stored inside here. You see, because when I press 4 or 5 or 6, this clock will change and then this input will move to here. So, and stored here, stored permanently. Not stored permanently, sorry, it's stored at the meantime. As long as you don't do anything, then it's there forever. Okay, and then right, uh, now my delete is 1. Okay, since my delete is 1, so my output of this multiplexer is 6, also 6. Okay, I add another one. Yeah, this one I connect to this. Okay, so this display is for the output and the output of this multiplexer and the input of this register. This display is for the output of this register. This display is for the input of this register. This display is for the output of this register. Okay, so when I press play, when I on it, so let's say when I press 8, okay, so this will become store as 8, and then this also will become 8 lah, because the multiplexer will choose that 8 mah, will choose this line and then become 8. Okay, so when I press add okay, you see this 8 will transfer to here. To show you again, I'll clear the thing 5, okay, you see some 5, then when I press add, then you see this 0 will become 5. Yeah, so when I press add, right, he will actually switch the clock. Later I'll show you the circuit, the logic gate the circuit, that part of the circuit which is connected to this clock. So when I press add, right, the clock will shift from 0 to 1, and then this input will move to here. Yeah. Okay, now next we focus on the output of this register. This output of this register is connected to this first multiplexer. It might seem complicated, but it's not actually. Why you want to connect the output of this register to this multiplexer is because this multiplexer will choose the left one when the delete is 1, but when the delete is 0, then it will choose the first number. Yeah, so basically, let's say I choose add then I add another number 4. Okay, so you see this part here store 5, and then this part here store 4. This 4 is your second number, and then this 5 is your first number. To demonstrate again, I will clear the thing and show you again. You see your first number will be here, your second number will be here. Okay, so when I press 2, see my first number is here, my first number is here lah. But then when I press add, this part will become your first number, and this part will become your second number. So like I choose my second number to be 9, So this part will remain the same, it will still become your second number. Well, it will still become your first number, but this part is already your second number. So you are in a state whereby you are choosing your second number now. My second number can be any of these numbers lah, but my first number is retained. My first number is stored at the moment. But when I press delete, this 1 will become the 0 as well. This 1 will become 0. So what happens is when 1 becomes 0, you will choose this part instead. So this 2 will go inside here and then will come out back into the input of this register here, and then will become the output of this register here. Yeah, so basically you are deleting the number here, and then at the same time when your delete goes from 1 to 0, when your delete goes from 1 to 0, at first your 2 will transfer here correct, and then at the same time that's for this multiplexer. But for at the same time for this multiplexer, when your delete goes to 0, you choose 0, right? So like I told you just now, all the logic here is 0. So that means this 0 will muscle into this input of this register, and this register will become 0. So you are actually deleting, you are moving the 2 to the first register back again, and then you are deleting the first number. Yeah, you are deleting the first you're deleting the first number lor. Yeah. Okay, so I show you again. Clear. 5 plus 4. Okay, so your first number is 5, and then your second number is 4. Second number can always change lah. You can change anytime, but your first number, which is 5, you cannot change. So if you want to change it, you press delete, and then this will go back to 0, and then now you are back to choosing your first number. Yeah, that's all. So that's the purpose of these multiplexers. These multiplexers is just for the delete function to work, so that you can go back to the original selection lah. After you choose the first number, then you have to choose the second number, right? If the user change his mind and want to choose the first number again, then this multiplexer will help transfer the first number, go back to here, and then delete. You can say delete lah. Using this 0 logic level, it will convert everything to 0. Yeah, that's all. So I think I kind of explain this this section here, okay, and then this section here should be fine lah, I think. Okay, so now where should I go next? The adding part. How do I keep track of the add? Okay, so you see this add the wire connect to this NAND gate, right? So you invert from 1 go to 0, and then go to this NAND gate. So these two guys here is actually, like I told you just now at the very start of the video, is to keep track of the state. So like when I press power, originally it's 0 when I press add, means I already choose my first number, and now I want to choose the second number. So when this light is on, is indirectly telling us that the user is choosing the second number. Yeah, that's all. Okay, now this part here is for the equal one, because like just now, when I press power, then I have 5 plus 3. That's all only. But you see my display here haven't calculate the sum yet, haven't display the sum. 5 plus 3 is 8. So if you want to display 8, you must press equal, and then this become 8. Yeah, so basically I need to keep track of the equal state also actually. So you see when I choose a number lah, let's say 5, and then I add, oh no sorry, need power first. So when I 5 and then I add, okay, so now we are in the adding state already. Okay, now when we are in the adding state, right, then only we keep track of the equal state. Okay, wait, I add the LDD first you see supposedly when I click equal, right, this guy will have the light up, but now when I click equal, this guy never light up. Why never light up, you ask me? It's because I only light up when this guy light up. Yeah, so that is the logic of this whole part here lah. If you want to understand why it works, you need to spend some time contemplating you need to stare at the sky, drink some coffee, and yeah, really think it through. But I'll just explain the function of this, okay? Because I don't want to go through the truth table and all those nonsense, yeah. So like when I press equal, nothing happens, but when I press add, see this guy light up, okay? And then when I press equal, oh, this guy light up. So that means this equal, so that means now I got two states. One adding state, equal state. So can you see here? When I calculate the equal, when I calculate the sum, right? Okay, where I clear it. 5 plus 3 equals to 8. So when I calculate the sum, which is 8, so I got two states, adding and equal. So I got two states on already. I press delete or clear, right? See, this delete is actually connected. Wait, I go back. Go back to here. This part here. This part here is this this part here is to keep track ma. This part here is to keep track whether you press delete, clear or power, correct? So this and then the output of this here, I connect to the preset of the two latch. So which means when originally the output is 1 lah, it's always 1 lah. See when I press play it's always 1 lah. But the moment I press power, clear or delete, this guy will become 0. See? It becomes 0. So when it becomes 0, then you will reset the state. This Q when this part here becomes 0, this part here becomes 0, your Q will become 1, and then your Q bar will become 0. Yeah, so basically I'll demonstrate to you when you press power, and then 6 plus 3, okay, equal. You see both states on. Then when I press power, you see both states become off again. Yeah, so basically power, clear or delete in this circuit will reset all the states, the adding and the equal state. Yeah, so when I press 3 plus 2, I never press equal, equal is always 0. Okay, at the moment it's 0 lah, because I never press. When I press delete, then my adding state will become 0. Yeah, so this D latch is very useful lah. I mean, you can set the state using add and equal and all the stuff, and reset it using delete, clear and power. If you want to achieve it, you just need a bit of logic lah, and then just play around, and then yeah, you'll get what I've achieved here. Yeah, okay. And so okay, the output of this equal part here is connected. Okay, don't care about that, because that one is to do with the display here already. The output of this adding latch, this is the equal latch. Why I call it that is because this is to keep track of the adding state lah. This is to keep track of the equal state lah. So the adding state here is connected. You see the Q bar, the output here is the adding state lor. So I connect it to the, what is it? The clock. The clock of this guy, this register. So that means you see the register will only shift the input to the output. The register will only shift the input to the output when the clock moves. Okay, and then you see the clock only moves when this part here moves. Moves means change from 0 to 1 lor. Yeah, so when I press power and then 2 plus, you see when I change the plus, and then this clock will change, and then this number will change from 0 to 2. Yeah, so that's the purpose of this latch. And also this latch is to keep track of the state lah. And then why I want to keep track of the equal state is because of the display here. You see this display, right, have to display two things. This guy here got a lot of things, got two things to do. One is he display the number that we choose here. Another thing is this guy here have to display the number that you have to display the addition of two numbers. Like clear 5. You see when I press 5, this number will become 5. Then when I add, I want to plus 3 lah, so this will become 3. When I press equal, this will become 8. Yeah, so that means got two states here, for this display. The states are either you display the number that the user choose, or you display the number that after you add the two numbers lah. Yeah, so then you see you have multiplexers here, 4 multiplexers. So the switch of this multiplexer here is actually, is actually the equal state lah. So when my equal is 1, then I will choose the addition of the numbers, the sum. When my equal state is 0, when my equal state is 0 means I haven't plus 2 number mah. I'm choosing the number first. I'm choosing a number first. So that means it will be 0, and then this one will be the number that the guy choose lah. See, the number that the guy choose is connected to the output of this register. See, the output of this register is connected to this multiplexer, and then when my switch is 0, I will choose the output of this register, and the output of register is always the number that you choose. Here, yeah. So that's all lah. This is the purpose of this circuit lah. These 4 multiplexers here. Actually, that's the purpose of these 2 multiplexers. You have another 2 multiplexers here. I will explain later. Okay, with the switch lah. I got one more switch here. I will explain later lah. So okay, now let's focus on the addition of 2 numbers. Okay, so you see my first number is stored here, and then the other second number is stored here. I demonstrate again. See, first number is stored here, which is 5. My second number is stored here, which is 3. Stored here lah, which is 3 lah. So 3, and then okay, see, in this addition circuit we already learned is you can find this circuit in our lecture notes. You have 2 addition, you have 2 full adders, first adder, second adder, and then the input of the first adder is basically the 2 numbers the 2 4-bit numbers. So you have the first number and the second number, which is 5 and 3, and then the output is here, and then my C in right is always 0. Yeah, because we are not we have no extra carry in there's no extra carry in it, so it's always 0, connected to low level. You can see this is low level, and then it's connected to C in, and then your C out right is uh your let's say your number here exceeds uh your number here exceeds 16 8 plus 8 16, right? But in binary form you go back to 0, so you got one extra carry here. Yeah, so this carry will okay, so like this part here, this NAND gates, this group of NAND gates here, you connect to the carry out, and then you connect to the fifth the fourth bit, the third bit, and the first bit. Yeah, this circuit here is in our lecture note. I won't cover. I won't explain why you need, why the logic is, why you need to connect it like that. But basically you connect it like that. uh the output of this connection is to show that you need to add 0110. Yeah, why you need to add 0110, I think never mind, I just read the lecture notes, and then you understand lah. So you need these 2 sums, okay, and then you sum these 2 numbers, you get the sum here, and then the final sum here you must sum it again to 0110. Whether to sum it with 0110 depends on the output of this part here. If you the output of this part here will determine whether you need to add 0110 or not. And then here's the final sum. Yeah, so you got 2 sums here, the sum before you add 0110, the sum after you add 0110. Yeah, so this part here, the sum, right, is actually in hexadecimal form, and then if you add 0110, you are actually converting it to decimal form. Yeah, so basically I got 2 forms here. One is hexadecimal, and another part here is decimal form, hexa and decimal. Yeah, so I connect it to this multiplexer lah. And then you see the carry the carry of this no, sorry, the output of this NAND gate circuits, right, is connected to this multiplexer here. Okay, see this multiplexer here is connected to 2 buses, one bus and the second bus. The first bus is all 0, you see, the first wire, second wire, third wire, fourth wire, all connect to low level, all 0. And then the second bus you connect to the first wire, the second wire, third wire, fourth wire is 0, but the first wire is connected to the output of this combinational circuit. Why? It's because okay, so the switch of this, right, is connected to the this switch, this button here. So when it's 0, I'll choose hexadecimal form. When it's 1, I'll choose decimal form. So 0 hexadecimal, 1 decimal. Demonstrate to you, I will choose another number lah. Power on 9 plus 9 equals to 18. But why you get 12 here is because this is hexadecimal form, you see? So 16 to the power 1, 16 to the power 0. 16 to the power 0 times 2 is 2. And then 16 to the power 1 times 1 is 16. 16 plus 2 is 18. So in the end you get 9. In the end you get 9. Sorry, 9 plus 9. Then you get 18 lor. But this is hexadecimal. So if I want to change to decimal form, then I press this. So you change to 18. Yeah. So you see, it will go back and forth. It will keep going back and forth. Let me go closer. Yeah. So this switch here is connected. You see this wire? I trace the wire for you. It's connected to the two multiplexers. Yeah. So if you see, when I'm 0, right, I choose hexadecimal mah. So that means I choose I0. Then I choose I0. Then when it's 1, then I choose decimal form lor. So I choose I1, I1. So that means this I1, I will connect to the decimal part here. Yeah. And then this I1, I'll connect to decimal sum. But you see, the decimal sum, right? You see the sum here. Sorry, the sum here and the sum here is always connected to the right side. The left side is actually the carry. Yeah. So if it's decimal form, you always, you've got extra, right? You always got 1. You see? So but if it's hexadecimal, also got 1 lah, but the one depends on this circuit here. This circuit will show you whether got extra lor. If it exceeds 16 lah. If it exceeds 16, then this output will be 1. Yeah. And then that's why you got a 1 here. If you want to, a bit hard to explain lah. So never mind, you just figure out yourself the difference between the hexadecimal and the decimal. All I'm doing here is just to explain the purpose of these multiplexers lah. So these multiplexers here is to switch between equal and choosing the number. So I can either choose the number or I press equal. So when I press equal, I will have to display the sum here. But when I'm choosing the number, I have to display the sum. I have to display the number that I'm choosing here. So that is the purpose of these two multiplexers. Whereas these two lower multiplexers is to change between hexadecimal and decimal form. Yeah. So if you just spend like a few minutes, connecting the wires and just analyzing this part, you understand lah why I connect it this way lah. Just read the lecture note, chapter 5. Yeah. Then you understand why. Yeah. And then that's all. So you see these 3 LED lights. Okay. These 3 LED lights is different states lah. Like you see this one connected to the what is it? To the equal state. And then this lower one is connected to the adding state. So this is for equal, this is for adding. So if I press add and also press equal, then these two will light up. Then if I go to hexadecimal, then this one is 0, right? 0 means hexadecimal form. Okay, so when I click the 1, it will change to decimal form, right? So this light will light up. So light up means decimal, never light up means hexadecimal. Okay, so I'll just expand it. I'll go zoom out to show you lah. So let's say if I off it, then I on it again. Power, you see, all off, right? Then when I choose a number, nothing is on. But when let's say I choose 6 lah, then I press add, and then you see the adding state is on already. And then let's say I choose number 2 lah. Okay, see, I choose number 2. Then I press equal. You see the equal state is on already. So that means I got 2 states, add and equal. Then when I change between hexadecimal and decimal form, it will this one will keep changing lah. Yeah. So when I press clear, I'll go back to start. Or when I press 6 plus 2 for example, and sorry, 6 plus 3 for example, and press equal, you get 8, right? 5 plus 3, then you get 8. So when I press delete, then you get 5 again. That means I'm choosing the first number again. Yeah, so I think it's pretty much good enough lah for our assignment. If you want to add anything, just let me know. Yeah. So what else? I think should be fine. I think yeah, it's quite nice lah. That's all. Yeah.